From the Library of Congress in Washington, D.C.
There's one over there. Okay, nice.
Oh, you can show me. What's yellow or something?
Yeah, I'm actually
Good morning. Good morning and welcome to today's program featuring archaeologist Tom Sever. I am Ron Bluestone, Acting Chief of the Library's Science, Technology, and Business Division. Today's lecture is the second in a series of 5 programs this year through a partnership between the library's Science, Technology, and Business Division and the NASA Goddard Space Flight Center. Before I introduce today's speaker, I would like to take this opportunity to thank my colleagues Peg Clifton, Allison Kelly, and Mary Jane Cavallo, and Jeannie Allen from NASA for their efforts in preparing for today's program. One of the great mysteries of all time, which today's speaker thinks is close to being solved, is what caused the collapse of the classic Maya civilization, with its magnificent ceremonial centers such as Tikal, Palenque, and Copan, and with its extraordinary accomplishments in art and science. The classic collapse in the 8th and 9th centuries has been attributed to such causes as peasant revolt, foreign invasion, overpopulation, a prolonged drought, and environmental degradation. Associated with the collapse is the abandonment of Mayan centers, especially in the Maya heartland, the Peten region of northern Guatemala. This has been described as one of the worst demographic disasters in human history. Tom Sever has been conducting research in northern Guatemala since 1987, using satellite and airborne imagery to locate and map Maya sites. He has used this technology to understand the dynamics of human adaptation to tropical landscapes in the context of climate variability. And he has found evidence of Mayan rainwater management systems which might have led to increased farming and in turn overpopulation and deforestation contributing to the collapse. Dr. Sever is a NASA senior research scientist in remote sensing and interdisciplinary research. He has been a pioneer in bringing remote sensing and global information systems technology to the disciplines of anthropology and archaeology. He received his doctorate in archaeology from the University of Colorado in Boulder and has more than 25 years of experience in environmental archaeological research. He is the author of numerous publications and the recipient of many awards, including the NASA Exceptional Achievement Award. And his satellite images of the Peten influenced the Guatemalan government to establish the Maya Biosphere Reserve, the largest protected park in Mesoamerica. As food shortages and deforestation are very much in the news, and as there are expectations for an increase in the human population from 6.5 to 9 billion within 40 years, Dr. Sever's research into the collapse of the classic Maya and what it may mean for our civilization is of paramount interest. And now it is my pleasure to welcome Tom Sever to the Library of Congress.
Thank you, Ron. Can you all hear me? Yeah, okay. Thank you for this nice turnout. Louder? Can we turn up the mic just a little? Or I'll just yell louder. How's that? Well, as we do that, as Ron had said, everywhere I go around the planet, I see the same thing in the last 20 years. This planet is changing, and there is hardly any place that is untouched. And as we look at all the pollution and the lack of water, right now our western states are having trouble with water. Water will be, I think, the key issue in the next 25 years, not nuclear war or oil, but water. And when I look at this, I try to think, how can I summarize this? So this will be the only thing I'll read. Plowed fields have replaced forests. Domesticated animals have dispersed wildlife. Trees are plowed, mountains smoothed, and swamps drained. There are as many cities as in former years there were dwellings. Everywhere there are buildings, everywhere people, everywhere communities. Proof of this crowding is the density of human beings. We weigh upon the world, its resources hardly suffice to support us. As our greed needs grow larger, so do our protests that already nature does not sustain us. Well, that was written by Tertullian in 200 AD as he looked over from his monastery in North Africa. The idea of pristine environments, I believe, is a myth. I think from the beginning, humans have transferred landscapes around the world, and that's what we're going to talk about with the Maya and a couple of other places. Archaeology and anthropology have documented the existence of 50,000 cultures in human history. 45,000 are now extinct. In most cases, they did it to themselves. There are events such as abrupt climate change, natural phenomena that humans have to react to. But then there is also what humans do to their environment. In Easter Island, that area was full of trees until the trees were gone. In the Anasazi changed their environment, salted their fields. And in many parts of Mesopotamia, it's not the desert we see, it was an oak forest when they lived there. An example of an abrupt climate change takes place about 2200 BC. This is obviously Egypt in the Nile River. And the area you see here is the Fayum. It's a 65-meter lake. It's today the center of agriculture for the Egyptians. And about 2200 BC, from 40 to 70 proxies around the world, something dramatic happened. Many civilizations, such as the Egyptians, Akkadian, Ethiopians, Harappans, were wiped out. They weren't, but they came close. They all suffered severe cultural collapse. In the Americas, we haven't attested to look at these dates to see what might have been there. It was at the time of the Old Kingdom that the Egyptians built the Sphinx and the pyramids and the things that people go to see today. But it was at this time, right after this, that they were wiped out to the point that if this is the Old Kingdom, the next kingdom is in here, is an intermediate period of a very small population. Some estimate 1/3 of the Egyptians died in what happened here. In some cases, this event seems to take place for decades, and others for a couple of centuries. But fortunately, from the Egyptians, we have documents of talking about this. All of Upper Egypt was dying of hunger, and each individual had reached such a state of hunger that he ate his own children. Dai is the river of Egypt. One crossed the water on foot. One seeks water for ships to sail on, its course having turned into shoreland. And the Fayum, that big lake that I talked about, dried up completely. It's the first time and the only time that we know of that this has happened. Looking at the Maya, one of the first pioneers of trying to use aerial photography in airplanes was Charles Lindbergh in 1929 in early October, flying with archaeologist A.V. Kidder into this area. Basically, it was not a successful enterprise. They took very few photographs. Their intention was great, but other than a few photographs, they never resolved how one might use airplanes to find sites. But what they were excited about is that this area was so weighed by vegetation, their outlook has been so stifled by mere weight of vegetation that it has been impossible to gain a comprehensive understanding of the real nature of this territory. And so it is with remote sensing that we can look at this area. Doing field work in this area of the Peten is time-consuming, expensive, and incredibly hot. Temperatures reaching between 100 to 119 degrees. I was asked to put in this picture, I usually don't, but we also encounter snakes, and my leg there are ticks all over me, which stay on me for 2 to 3 weeks. And as I say, when I come home, my wife gives me my own bedroom for a couple of weeks. But fortunately, from remote sensing, we are able to analyze this area at the regional level. For those unfamiliar with remote sensing, we look beyond the range of human vision, and go out into the far reaches of the electromagnetic spectrum. And through the use of detectors, we record invisible information. And through the use of computers, we bring invisible information back into visible light. In this way, we truly see the invisible. It's a more technical term. We say we measure this energy in terms of watts per square meter per micron per stare radian, but it basically says we can look at different parts of the spectrum at resolutions and see a signature that is unique in the universe. And with GPS technology, we see things that are invisible. We can go stand on them and not see them there and may have to excavate. And so as a result, we use GPS technology to take us there. There is a casualty to all this. In the early days, we used to look like Indiana Jones. Now we look like nerds. By the way, the advertisement found this picture of me from 20 years ago, so I apologize for getting old in the meantime. This is an example of some of the Maya cities. This is from 1990, National Geographic. My friend George Stewart provided me with this. We have since stopped putting up any known Maya sites, obviously for treasure hunting. But it was in this region that the Maya civilization flourished. They had an intense population. Don Rice, which is on the higher estimate of the population, maintains that around the cities there were 1,800 to 2,600 people per square mile, and in the rural areas 500 to 1,300 people per square mile. The only place today that competes with that are the most densely populated areas of China and Java. In Alabama, where we come from, my wife and I, the population density is 70, and yet we see people everywhere as we're down there. Around 800 AD, something dramatic happened. Within a short time, the population died out. The outside periphery seems to be the place where there is survival, although those populations lost 80 to 90% of their population. It's why we still have Maya around today. The question is, what happened? You have to remember that in this region, they cannot reach groundwater. They depend completely on the rains and build a system of reservoirs to harness these rains. But there was never a problem because the gods always brought the rains. It was the most stable thing in the universe. So we have over 100 explanations of what happened to the Maya, hurricanes and so forth. In fact, the word hurricane is a Maya word, huracan, god of the wind, but a literal interpretation is one spinning upon his crippled foot, which tells us the Maya either were able to look at the pattern of trees after a storm, or someone was in the center and saw that the storm was circular in nature. There have, as Ron, who introduced me, had indicated, over 100 explanations, peasant revolt, warfare. Certainly all of these are components, but one of the things that we think did contribute to this was climate change. The question is, how much human-induced versus natural variability? Just quickly about the Maya, they were incredibly brilliant. From their astronomical alignments in the architecture, we can find that they knew the cosmos well. And from books such as the Dresden Codex, one of 4 books that survive, we know that they were able to make astronomical calculations that are almost phenomenal. Bishop Landa burned all the books, and these are the 4 that have survived. What they could have told us about water management, agriculture, things that we don't know today, things that the current population sits there not knowing what to do with this landscape. In fact, when Cortez came through this region on his way to Mexico City with the Aztecs, this place was so desolate, 700 years later, he and his men almost died just trying to get through it. So it's from these books, and if we didn't have the Dresden Codex, we would not be able to believe or actually document that they could follow the planet Venus in the sky to a 2-hour air every 500 years. And they could predict a lunar eclipse to an accuracy, an error of 1 day every 4,500 years. They were truly brilliant. And again, around 800 AD, there is a collapse. The question is, how fast does this take place? And we don't know. Some offer a massive thing that wipes them out, which I don't believe. But little incidents such as this, every 20 years they had to erect a statue called a stone monument to celebrate the Khatum. And it's every 20 years it was a ceremony. In the year 790, we find 19 cities erecting it. In the year 810, we find 12. In the year 830, 3. So how fast does this rate? I maintain that it does take 100 years. The last date is in 894, I believe, but does take a long time. But towards the end, there's a group that we call the Aznab, which are similar to people surviving a nuclear battle. They have lost the great Maya culture, but they're still in small numbers around, and eventually they are gone. This is the forest as you look out today, and this is what we think the Maya saw. I'm at the site of Mirador on top of a pyramid, Danta, and as you look out through there, you say, yeah, the Maya were interacting unanimously and environmentally conscious with this. But this is what the Maya saw. In fact, the forest in the background is an exaggeration. This slide, by the way, comes from an article in National Geographic. And what you see here is look all the lime and lime plaster that is in the construction of this city. And these cities are everywhere, and they all look like this. Well, to make 1 square meter of lime or lime plaster, you have to burn 20 trees. Convert all of that architecture into trees, and then add all the people who have wood houses and wood for burning, you are looking at massive destruction. In fact, their landscape would have looked like modern-day China. Instead of rice fields, it would have been agricultural fields. I was trained as a desert archaeologist. I was having fun working in Jerusalem and Israel, and my dissertation is on the American Southwest Anasazi roadways. But in 1987, NASA and National Geographic joined together to try to do a salvage project along the Usumacinta River between Mexico and Guatemala to save as many sites to study, and before they were flooding, the modern-day Lacandon Maya would have been moved. But when we produced this image, everything changed. I immediately became a forest archaeologist. And I still miss the old days. But here you can see a political border from space. Mexico has cut down their forests. Guatemala is intact. There are a bunch of dynamics that handle here. Evapotranspirations, heating, pollution, contamination of the water system, salinization, all these things are going on. But again, from space. Well, this picture was so powerful that it caused the presidents of Mexico and Guatemala to shake hands to end their 150 years of tension along this border. It was a picture that united two countries. From that, the Guatemala Congress created the Maya Biosphere Reserve in 1990, the largest protected forest in Central America. This in turn led to the creation of a project of the Mesoamerican Biological Corridor, which we are still working on, to create a continuous tract of land from Mexico to Colombia to allow the continued migration of birds and animals. Because if these corridors are interrupted, the biodiversity of two continents can change quickly. And this led to the establishment of NASA's regional project. I've heard its first regional project, Severe. I am the principal investigator, but it is Dan Irwin, the project manager, who has done so well with this project. And what we are doing is we have created a monitoring and visualization system looking at 30 different types of activities in Central America to see what's going on. We have a facility in Catalac, which is the abandoned military base there, and we have about 30 Central American scientists there whom we interact with from the Marshall Space Flight Center. And these people, in turn, relay their data almost instantly to the other countries throughout Central America. This has gone so well that the GIOS has the Global Environmental Observational System of Systems, a bunch of buzzwords. 70 nations have looked at Severe and consider it to be the template to be used around the world. And we have already opened up a facility in Nairobi to start in Africa, and we'll be doing in other places. Basically, what we do with Severe is we put all the data out there for everyone to see. You can't argue or debate it. You can argue the data, but the data is there. So you can see what's happening in your landscape. And we even have pictures of children in Guatemala in mud and thatch huts with laptop computers looking down at their place to see what's going on around them. In 1986, I took this is our border again, and everything you see in red are healthy trees, but again, this is the protected area of Central America, part of it. And 1986, 1995, look how fast the deforestation takes place. So we were working on projects which we called hot islands. How do we save the biodiversity of these small islands? But that was mute because they turned into agricultural fields and it's gone. Originally, I would fly down a road and look out each side of the plain. It looked like an ocean of green. And now you look down, you say, where's the forest? Unfortunately, this is happening around the world. And other than Sting singing about it, which no one cares about, you know, the fact of the matter is, it's so overwhelming, the rate of change on the planet, that there's no way to process it. It was in 1992 that the locals started asking me, what's going on? And I said, what do you mean? They said, well, you work for NASA, you're smart. Anyway, the weather's changing. And I said, well, that's interesting, but you know, that's not what I do. And I said, what do you mean? And they said, well, by the Feast of the Holy Cross, we had to have everything cut down and so we could burn it because the rains come. Now the rains aren't coming for 1 to 2 months later. What's happening? So we started looking into that, working with atmospheric modelers and people in Marshall, and what we were finding is that, for instance, over the deforested areas of Central America here, the cumulus clouds, the rain clouds, are forming higher later in the day, resulting in less rainfall. For instance, a rain cloud should be at 600 meters at 9 a.m., but over the deforested it's already at 1350 meters, and by the time it's time to form, it's gone. So rainfall's been diminishing, and when the Maya filled up all their reservoirs, they had an 18-month supply of water. A 3-year drought would have been devastating. In Alabama last year, we had a drought that lasted for about 5 months, and it was devastating. The crops were lost, the cotton was gone, the horses, not enough hay to feed them. So you can imagine what this could have happened, a drought in this time frame. We were one of the first to study the bajos. These are the seasonally flooded swamps. Conventional theory back in 2000 was that nobody really lived out there. They're inhospitable, they're hot, they got scrubby, thorny vegetation. But our connection was that, then why are all the major Maya sites sitting next to the bajos? The bajos must have done something. The Maya don't settle by the rivers and the lakes to secure water. They are out here. These things must do something. So we began with Pat Culbert, University of Arizona, and Nick Dunning, and recently Bill Saturno. We began looking into the Bajo system. One of the things we found that was pretty obvious are the roadways, the causeways that are going across the landscape. We can see where cities are, how they interconnect, and so forth. We were the first ones to do a survey of the Rio Holmul, which goes down through here and connects 10 of the major Maya sites, and found that between 750 and 800 AD, the entire river dried up. At a minimum, in some places, it was just swampy, but mostly it dried up. And subsequent researchers have verified this. Hodel, Curtis, and Brenner indicating that it's a worse drought in a 7,000-year period. Peterson and Hogg saying it's a 100-year drought that have spikes in 810, 860, and 910 AD. And Carlin saying that this is a 3,000-year, the coldest temperatures up there. What's happened is the North Atlantic high has come down and is keeping the rains from getting up above. The rains are not coming into this region. So we started looking into climate. One of the first things we did was, can we explain the 2001-year drought? It wiped out in Guatemala the coffee crop. It was uninspected, unanticipated, unpredicted, and so we started to see, can we start doing this? And then, what is the role of deforestation? How does it change the climate? And what are the future scenarios for Central America? And finally, can we regress this model to have a better understanding of the Maya? One of the models that we run is MM5, Mesoscale Model 5. It's been updated to a thing called WRF right now. But basically what we do is we look at the landscape, and when we replace this landscape, instead of the trees that are there now with the landscape the Maya had, we see a 2 to 5 degrees centigrade heat up in temperature, which is significant enough to cause a 20 to 30 decrease in rainfall. Then the question is, well, what is normal patterns in this region? And so we run another model called CCSM3, Community Climate System Model version 3. Model 4 is going to come out next year. But in this model, we put in the forcings of volcanic eruptions, and different criteria which will change temperatures. And what we find is in a 100-year period, you can have 24 of 30 years of below average rainfall. If you take this normal drought and add the Mayas 20 to 30%, you create a scenario from which they could not survive as one potential example. And these are the kinds of things that we're looking into to see how extensive was this. In the Bajos, we are also finding water reservoirs, canals, and so forth. And here we see a water reservoir. It's 300 meters on a side. We found what looked like to be a canal coming in and one going out, connected to a site up here called Posamaya. And in these canals, just to show you what's going on, here are two canals parallel to each other. And this is the soil, if you will. When you get here, you hit the limestone, the escab that goes on forever down through there. So that's how thin that soil is, and this is why people deforest, to get all the nutrients from the trees to make things grow. So when we looked at Posamaya, which has 60 temples, 11 main plazas around me here, I'm standing on the ground level here with Pat Culbert, and that's, by the way, Dan Irwin, head of Surveyor, our project manager, and we're looking down. We should only have to go this far to see sterile soil. And the explanation when we found these things was, okay, at the time of the collapse, things were so desperate, the Maya were going out there. So in looking at that, we see the Maya have been there a long time. In fact, their occupation of this area is in direct correlation with the urban centers. We found these features out here. The Bajos will fill up with rain, and then they will evaporate and dry up. That's when we go do our field work. That's when we almost die. Bill Saturno's camp runs water 24 hours a day to keep his 130 people, excavators, alive out there. The Maya had all the water in the world. How are they doing it? In fact, you can't build during the wet season. You have to build during the dry season. So how are they managing water? So in these, when these things fill with water, we see these elevated islands, and we have gone to 120 of them. We have mapped hundreds of them, but in going to 120 of them, on each and every island, we have found a major city, a minor city, a hamlet, or a bunch of house patterns, never an absence of human occupation. The study of the canals started back in the 70s when canals were found in Quintana Roo, and it was thought that if they have them here, certainly the Maya heartland must have these canals. Well, for 40 years, we've searched and haven't found them, and until recently. There was an attempt to use radar, and in 1981, Adams, Brown, and Culbert in Science produced an article talking about how they had found the canals using radar, but it turns out they were just seeing backscatter patterns at these images, other than the big major canals, were in error. And so it was in looking at these images in 2004 that I started to see features which I thought might be canals, and started taking the images to stream morphologists and geomorphologists and say, I don't know anything about this, but what do you think? Every one of them said these are man-made. So working with Nick Dunning, University of Cincinnati, he is taking his team out in here last year, and then this year, 2 weeks ago, he went with the person who works in my lab. I was unable to go, unfortunately. And what they are finding is confirmation that these are indeed human-induced canals. You can tell by when they dig and they pile the dirt up on the side, and we're waiting for the carbon dates just to make it absolutely crystal clear that that's what we have. We have an article ready to go. We hope to put it in geoarchaeology, but again, we need the carbon dates just to be sure. But there's no doubt, archaeologically, these seem to be human-made. Interestingly enough, outside the site of Tikal, we see all of these patterns, which we don't know what they are. We've gone to them. We know that they are not of recent origin. Some people said they might be 1930 transects from oil lines or so forth, but they are old. We just don't know what they are. We haven't had time to excavate yet. And this summer, 2 weeks ago, they went down and investigated this area. But they looked at 2 canals, and we have 24 to 36 canals just in this region. So this is a lot of work, a lot of money to get out there, a lot of effort to confirm all of these. But our suspicions are that we have found them, which will end 40 years of theorizing that they really do exist there. Also, we are looking at the connection between the canals and these areas here, which we call aguadas, which are water storage areas. We as you look at the images through time, you'll see that the water evaporates and these last areas are there. Well, that would be natural. But now we're starting to see they seem to be human modified, as though these are the ways they're storing water. In fact, one little bitty aguada here can store 30,000 liters of water, which is enough water for 25 people for a year. Is this how they are doing it? They're managing water, they're using the canals for transportation, they are storing water for agriculture, they are making fisheries out of this, aquaculture and so forth. We don't know the answers to these. Our first step was to find them. Concerning the bajos themselves, it turns out that many of them were freshwater lakes, as indicated by the existence of cottontail and other new plants that Nick Dunning has found. And that from the deforestation, these features silted in and created the scenario today. He calls it the greatest human-induced environmental transformation in the history of the pre-Columbian New World. Humans modified, changed 40 to 60% of their landscape. We're also trying to look at energetics. How can you grow corn in this area for modern day cultures and for the past? And so we put up transects through this area. And what we found from talking to locals, every 100 meters, we'd take someone and say, what do you see? And they would say, we see this. We saw chaos. And we did this until we had a vegetation class, of which this class in particular is the best one for growing food. During the dry season, it maintains 65 to 85% of its moisture. The next best are the upland forests, which are 33%, which are not good for dry season agriculture. So what we're trying to do is map these areas and verify how productive they are. Rob Griffin, who works with me, again he's from Penn State, finishing up his PhD. He's with us down at the Marshall Space Flight Center, and he is putting in these fields in these different areas, and here you can see an example. And the best type, look how halfway through the season the agriculture is growing versus the second best, and the other ones are basically much worse than that. We wish we had a final picture here, but someone came and harvested our products, so we'll do better next time. And again, the ultimate thing is to get a Bajo classification. And then when we start to look at the landscape, what is the perfect scenario for two households to live on this? Each household needs 42 fields that you put them in a fallow cycle and it regenerates. And when you do this, over 20 years, 50 people can live in this landscape. The yellow again would be the, if you will, the deforested, or while the others are coming up. If you go to a 5-year fallow instead of 20, you have 170 people. If you do 2 years, you have 340 people. And then no fallow, you can have 1,000 people, which is starting to get close to the Maya population with no fallow period coming back, no regeneration taking place. And so we are also looking at the rate that this might have changed. And we have stumbled onto something. Bill Saturno's excavations at San Bartolo and Francisco Stradabelli's at Chiltún have showed us that here are two cities. They're only 8 kilometers apart. One of them, San Bartolo, is gone in the late pre-classic. In fact, the final layers are like an inch thick of the clay and lime plaster, means the trees are gone. Whereas Chiltún just flourishes. It's only 8 kilometers away. It stays and grows and grows and grows. What we think happens is that as they deforest an area, it's basically useless. They move somewhere else. They try new techniques. They manage it better for a while. But cumulatively, these things start to change and start to aggregate into a regional kind of result. And this is why we are currently running OLAM, the Ocean Land Atmosphere Model, and this is going to allow us to put in these parameters to see, based upon the archaeological data, what's going on. And in this regard, we more than ever need to time in with my archaeologists with their information and their field data, because we think this might be extremely important. And again, as I said, been working with Bill Saturno, who is on a NASA IPA at the Marshall Space Flight Center. He is just now leaving San Bartolo, by the way, after his field season. And he, of course, is known for finding the oldest murals in the world, which predate the only other mural ever found. I see some not knowing what that is. Well, the only mural ever found was found in 1946 at Palenque, and it dates to 800 AD. Bill's mural that he has found predates that considerably. In fact, perhaps 100 BC or earlier, at a time when we didn't think the Maya had writing and all these other things. And in fact, This is the crown being put on in the mural. That's the crown that Maya kings will use forever. Here is the hieroglyphs, which are much earlier, 500 to 700 years earlier. We don't know how to translate them, but they've got writing. And they have paint and all the things that we normally would attribute to the classic. As Bill Saturno says, finding this was like finding that there was another Renaissance, another Sistine Chapel at a time when we thought it was Dark Ages. But working with Bill, we have come across a very important discovery, and that's from the vegetation here. Remember the lime and lime plaster I showed you? It is our feeling, and all the data we have done so far indicates that after centuries and centuries, that lime plaster is still affecting the vegetation on top. So we are mapping these structures. It was first noticed with the traditional mapping at San Bartolo and the correlation between the vegetation. And then we started looking at larger structures and seeing them. And so we went out, because I was pretty skeptical of it, and we went out and looked at scores of sites. And it works this way. You're walking through and you say, in 200 meters, we're going to come to the next site. In 50, in 10. And you say, there's no way. And then boom, there's a temple there. And then you walk across and say, 150 meters, we'll be leaving. And then boom, there's nothing there. And you do this with 1 meter accuracy over and over again. And as I said, we did this, and I became absolutely convinced. Because one of the things that Lindbergh and Kitterflight were trying to do was find a vegetation signature. And they claimed they had found it, but they never told anybody what it was. And we don't know what it was, but it can't be what we've done, because they didn't see in the invisible wavelengths, which is where we're finding this. To find these clay models, these lime plaster models, you would say, well, that's easy when you have a complex like this. By the way, this is going to be big news. Bill's just told me, for my archaeologists, if you know the E complex at Huachatun, this might be something pretty significant that he's found at San Bartolo. But so to find this, you would say, yeah, the lime plaster affects all this. But take a house pattern, something about half the size of your living room, with the clay only a foot tall in an area. We're finding the house patterns in the vegetation. And so we see, as we look at this landscape, that if we take the bajos and the vegetation, this pristine forest that we look at is 80 to 90% a human artifact that we are seeing 1,200 years later. What are we doing with the populations that Ron, who introduced me, was 6.5 billion? What permanent things are we doing in our landscape that will be seen for thousands of years into the future? We see innumerable sites. We see a major site out there, and this will be one of the areas that we will address in our future ground research. We have taken the signature and gone into the Amazon, and in there, not from the lime plaster, but from terra preta. It's a human-induced soil. It's human-made. It is 800% more fertile than the adjacent soil, and if you just let it rest for 5 years, the leaves fall, it refertilizes, and they were building on top of these areas, and we are just overwhelmed with how extensive through the Amazon we see the signature. We have flown over it to do a preliminary analysis, and also from the raised fields. This is one set of raised fields in the Amazon, and there are hundreds of them. We think there may be more than hundreds of them. We are also working in Cambodia, doing the same kind of thing, again going back to a lime plaster situation, working with archaeologists from University of Sydney and other archaeologists, southeastern archaeologists. And it gets us to the conclusion here. The Maya were incredibly smart, as we have indicated. There are two schools of thought. Were their kings so arrogant that they just dismissed what they saw going around them, or did they not know or truly appreciate the consequences? We ourselves will not have that dilemma. We can see what's going on around us. We can measure these things. We can see what's there. We can work through Surveyor and put this data out to everybody everywhere. But the question will rest with decision makers. What will we decide? And is that going to be the fate of the 45,000 who are extinct? And finally, I just want to say, for my Maya archaeologist friends in general, for 27 years at NASA, I've had the honor of working with them. But last year, NASA, for the first time, made archaeology a genuine scientific discipline in their program, because they think it will continue to give information so critical and understanding our future. We have lake course sediments, we have ice sheet sediments, but the archaeological information is something that has been overlooked, and we have that information, and it is truly powerful. I remain an optimist for the future. Thank you very much. I didn't know if anyone had a question or two. If it's on archaeology, I want to defer some of my great archaeology friends in here. Yes?
What was the site? I know that the vessel terminal with that was going to be big news.
San Bartolo?
San Bartolo, but what about it specifically?
The site is very early. And he says, and he hasn't told me what it is, but he's found some exceptional architecture. And he, it'd be not my point to bring it out, but to give you an alert to that I think he'll have some great news on it. Bill is just an exceptional archaeologist, and we're proud to have him. It took me 27 years to learn remote sensing. It took him 2 weeks, I do believe. But anyway, yes.
In one of your early slides, you had a map showing various sites. It seemed to be like a hole.
That was the hole. In 1990, that was the hole. No one knew what was there. And we have archaeologists now who are working on it. Charles Golden and Doug Comer are working that area right now, and I remain optimistic of what they're going to find. But that's why we did that area first, because nothing was known about it. We were going to do the river, but we were going to go into that region, which I did, only to be captured by the leftist guerrillas, and that's a different story in itself. Field work didn't go well at you. Yes?
Kind of a naive question. If you go to the Google Maps and you look on Guatemala, there's this thing that's appeared on 2 of your slides, a pretty big wide area, and when I take a regular road map, I can figure out what it is. Google doesn't tell me.
Is it in the western Peten?
Yes.
Is it square?
Yeah, a series of squares.
That was a
It looks
retired.
like an archaeological dig. Who knew that?
Right, it's a retired, I believe, military officer who went out there and made himself a big giant plantation system.
Okay.
Yeah,
That makes sense.
yeah, and yeah. Since we're on webcasting, I'm sure he makes a good employment out there. Yes.
What is it about trees growing over old lime plaster constructions that makes them look different?
That's a good question. That's what we don't know. We theorized it is the stress, and we think there's actually a difference in species. And we have people, one from Duke, who's going to start addressing that right now. We've had a couple of people lined up, but they didn't show up, and so we don't know. But one of the, there's an article coming out now that is being written about people who worked at a place north of Tikal, and their technique didn't work out as well. Well, one of the things is their data they had, well, first they had post-processed data, which you have to have the raw data if you're going to do this. I mean, it's any tree of knowledge. You can't start up here. You can't get back there. You got to start here to technically get to that place. The other one, and this is where I think there's stress, is their data was in December, which is at the end of the rainy season. Our data is at the end of the dry season when this thing pops out. So I'm fairly well convinced it's stress. Now, in the western Peten, where you don't have, it's an elevated, higher area, it may be that the earlier data, I don't know, I haven't looked into that. But that's a good question. Are you a botanist or anything? Because we could sure use you. Okay. Yes?
Botany, I was looking at an old science journal just recently, and I saw the article because of your talk here. It mentioned that botanists back in the 30s were going into Guatemala to track about 1,000 different types of flowers.
Right. That was Lundell who was doing that. And
Change or so? I mean, the flowers change because of any conditions?
well, recently I don't know, from the time he was there in the 30s and so forth. But going back earlier, we don't know. I am convinced that the forest that the Maya saw is not the forest we see today. It's a completely different forest. Different vegetation has grown up, which seems to be the indicator of what happens in other places around the planet. But it's another area of research that we need to go deeper into.
And the other thing is more of a personal level. I just, in the New York Times, Christoph's column talked about vampire bats in Central America, and I thought, my God, I want to out there.
Yeah.
You worry about stuff like that when you're out in the woods?
Oh, yeah. Oh, I'm a wuss. People don't understand. I'm a big baby. Oh, no. I've had a vampire bat on the back of my leg and, felt, what's that warm stuff, and looked down, and then didn't mind that, but it was the rabies shots that were the pain and everything. I have malaria. I have all that stuff.
What
So.
do you call that when you go out like that? Like astronomers talk about going to the mountain to look at stars. What term do you use?
Field work. We're just going verification field work.
Oh, it's not very exciting.
No, it isn't. My wife wouldn't appreciate potentially die, because I do put my life insurance policies on my desk before I go. Yes.
Are you finding that they manage the levels of these reservoirs, and are you finding how they control?
I am not, but Vin Scarborough has done a lot of work in there, and the answer is yes. They certainly were managing the city water supplies real well. And this is why we think finding these canals to give this type of information to Nick Dunning and Vern Scarborough is going to really explain how to use this area. They want to put a 5-star hotel out there so people can come and visit and see it's one of the few places you can go see animals and sights and monkeys and plants and all that, but there's no water. And so if we can rediscover, because people aren't going to a 5-star hotel if there's no swimming pool. So anyway, that's one of the things that we're trying to rediscover, so that people in this area today can use this landscape. Because what's happening right now is when they deforest a region, the first year they get 100% yield of corn. Second year, 60. Third year it's below 30, so they don't use it. So that place is left for the next hundreds of years they put cattle on it just to own it. And it's a useless landscape. So, but the Maya, as much as we criticize their collapse, the fact is they went for centuries succeeding. It's just, what was that threshold they missed to cause the collapse? Yes?
Are you working with Michael Heckenberger down in the Amazon?
Yes.
And is there other places besides Angkor Wat? I know that people working down there too. Is there like a wish list of places that you could use what you guys?
Oh, there is. And one of them is Africa. Africa is one of the great untouched cultural resource. There's stories of like a wall going across for hundreds of miles and things like that. I don't know. But many of the people that work in the area do tell me that they find something significant. Just received an email from Venezuela of something down there. And where we're working at Angkor Wat, we're actually going north of there out into an unexplored area. The other person with Heckenbergers that we want to work with is Clark Erickson, who's doing some great work in Bolivia. And this is one of the Heckenberger is just spectacular. I'll do a quick thing because I think it's important. Michael Heckenberger is an anthropologist, and he was in this village a few years ago, and he started talking to the people, and they said, well, this used to be a big site. And so anyway, they said, well, there's no big site here. And they said, oh, yeah, there is. So they dug down and they pulled up pottery out of the ground. Then they took him down to the edge and found more pottery, and this is where the whole idea of terra preta starts. And then it's when you look at these sites that you see, my goodness, these things are connected by 50-foot roadways. And this is what Heckenberger had put in an article in Science. And we were in the field when we read his article, and we said, well, he's not seeing the sites, so we downloaded an image and could see the sites, and that was our initiator, and we've called him and talked to him. The thing about it, though, is Orellana in 1541 went down the Amazon River, and it was at this place he talked about cities connected by 50-foot roads, and he met the Amazon woman and so forth. And it was all considered to be a legend, but we think that much of the Amazon was cut down and had a high population, and we think that will be the big news of the future. Yes?
What's your source of labor in your field schools? Are you using any local labor that shows up recently, or are you also incorporating field opportunities for the local universities?
The answer to that is, personally, I myself, an NASA employee, just take a small crew with me, 5 to 6 maximum. But working with someone like Bill Saturno, who's excavating and so forth, by law, they are required for every American to have one Guatemalan. And all the data, everything, all the classes are taught in Spanish. Everyone has the data. So the answer is yes. The people we work with are very conscious of that and work closely with and we do that around the world. I have done that from the very beginning. Whenever I left an area, I gave all my data to the people so they knew that this isn't scientific imperialism. This is your data, and let's work together. And this, I think, is why Surveyor became famous. It was on our the trust that we had garnered over a couple of decades. Yes.
You flashed a map, black and white, not very distinct, of what were thought to be cities or temple sites. How many of them do you think there were, and who made the map, and on what basis?
Oh, that first map?
Well, it came about.
The National Geographic dots? Yeah, George Stewart is the one who had given it to me. I don't know who in particular. I imagine George had a lot to do with it.
And how were they
Determined? From conventional, each archaeologist or one team would go, do the survey and find these sites, and then collectively all this data was put together.
And the total number, approximately, was?
Oh, it's in the hundreds, I don't know. But we think there's more than that. You're not even counting these Bajo Islands that we see.
Maximum, what does anybody think the population was?
Some go as high as 15 million, some say 8, 9 million. It's in that vicinity. But what they all agree is that no matter what that population is, 85 to 95% of them die at that time period. One more, and then
Some of the graphs that you had that show the extreme variability and drought didn't go back to earlier than the pre-classic.
no.
And I've seen some recently. I think Tim Beach has done some work on
Yeah.
showing greater variability in the area even prior to the pre-classic.
Right.
This is not an unusual or suddenly population-induced variability. It seems to be a pattern in that area.
Right, and you have, some maintaining Hodel and Curtis solar forcing flares that, sun flares that are changing this and so forth. What we want to do ourselves is the CCSM3 model only goes back about 2,000 years. We need for it to go back farther, and that's where CCSM4 will give us that data. It will go back 10,000 years from the new ice core and all this other data. There is a version out there called CCSM 3.5, and we're working with people in our lab and a guy named Bob Oglesby, University of Nebraska, who used to be at NASA, and he's gone there now. So we are looking at those new models because those are the very kinds of questions that we want to answer because we're intrigued by what Tim has found and so forth. Yes?
Still on the subject of information that passed so fast we didn't get. Where are the 4 codex?
Okay, the Dresden is in Germany, the Paris in France, Madrid, Codex in Spain, and the Growler is in New York, and it was considered to be a fake for some time, but recently there seems to be, most concede that it seems to be genuine. It was in a very bad condition, shape when it was found. They're all interesting, by the way, all those codices.
With respect to taking notes, the library is going to has taped this and filmed it to be webcast on the library, on the website of the Science, Technology, and Business Division, and the library as a whole.
It takes a while to get up, though.
How long do you think, Mary Jane?
It can take a few weeks.
A few weeks.
Well, our theories will all be wrong by then. Yes.
Well, so what's your suggestion for avoiding the fate of the Mayans?
I teach a course called The Collapse of Societies, and I'm 60 years old now, and when I started teaching this 2 years ago, I thought, I'm not going to connect to these young whippersnappers and, the Britney Spears era and so forth, and I haven't, I don't like them, I don't understand them, I'm just an old fogey, and I'm content to do it. If I go teach this course and confirm it, it's not what I found. Of my classes, for instance, the first class had 10, 5 changed their majors because they're worried about the environment. The generation that's out there in academia, in the colleges, they know something's wrong, and there are those who want to do something about it. This is why I am invigorated. I'm going to be teaching 4 classes and so forth, and the answer is the technology. They're learning remote sensing. They're learning GIS technology. They're concerned about it. They're arguing old fogey ideas like mine and challenging them. They actually want to do something. It's been like when I started out in the 60s, that kind of vigoration there, and I've been completely surprised by it. And And in my emails, I receive 45 emails an hour. And I would say that many of them are people who have heard, students that want to come from around the world, and so forth. Dan Irwin and I went to Panama 2 weeks ago, and with a 48-hour notice, the lecture hall had 300 people, mostly students in Panama, who wanted to hear about the technology and so forth. So it's a long answer, but that's how to give these people the education, the tools to see what's going on, because a lot of people my generation just don't seem to care. We seem that we've got X amount of time, we'll be okay for 10 or 15 years, but they don't have that luxury. So. Well, with that, I'll say goodbye, and I don't know if you had anything to say? All I want to say is my wife, it took me 20 years to get her to Washington, D.C. This is our first time, so we're going to go see the sights. So thank you for your time.
Just splendid. Thank you so much.
Thanks.
You're a national treasure.
Well, thanks for the...
Day over 35.
Well, thanks. Well, hey, how you doing, Dr. Saturno? The other one. This is Bill's brother.
Oh, hey. You got good press.
But I didn't know you were going to say yesterday, so.
Hey, it was good to see you. You haven't met my wife, Candy, so I'll introduce you. Are you in a hurry to get on? Okay.
Hi, I'm John Frost. I'm program chair for our local.
This has been a presentation of the Library of Congress. Visit us at loc.gov.